If we take a look at that worksheet. The first one looks like this. Okay. Writing polynomials. That's where we're going. Okay, we've already found the zeros of polynomials, we've factored polynomials. Now we're going to go the reverse of that. I'm going to give you the factors, I'm going to give you the zeros. You're going to write the polynomials. Now, keep in mind, what do you know about polynomials? What happens if a polynomial is of an odd degree? What's an odd degree polynomial? What's an example of an odd degree polynomial? X cubed. What do you know about x cubed? What do you know right now? The graph of the x cubed pops in your head. What does it look like? Like that. Well, so okay, so what's the left side look like? Left side goes down. What does the right side do? Right side goes up. What happens if it's negative x cubed? Reflected across the x-axis. Okay. Now, in the case of this one, yes, it could go either way, because if we take the function y is equal to negative x and y is equal to negative x cubed, yes, there is. You're not going to be able to tell the difference between when it's reflected over the x and reflected over the y, because it's going to be, in a sense, both. Okay. A reflection over the x of this is a reflection over the y as well. It's the same thing. Okay. Now, when we go through this, that idea is something that we need to keep in our mind. So odd polynomials, all odd power polynomials, left side goes, right side goes down. When what happens? When A, what's A? Is the what? Not the slope. Which one? Leading coefficient. When the leading coefficient is what? Positive. What happens when the leading coefficient is negative? It goes down. What happens when it's an even power polynomial?
Like that.
Okay, it looks like a quadratic. What do you know about a quadratic when A is positive? Both sides go up. What happens when A is negative? Both sides go down. So keep in mind, and it came up, but if on the Google Classroom is there, if you have a polynomial is always going to be in the form. Now, this is a cubic because we only have x, x, and x, which comes out to be x cubed. But this can go on and on and on for as many factors as we have. It can have 4, it can have 5, it can have 6, it can have 7, it can have as many as we need. As long as these A, B, C, and D, or whatever, are roots of my polynomial. Keep that in mind. I can write any polynomial to any degree as long as I tell you what the roots are. Yes?
So if A, B, C are roots, and then D is not, but E is, so it's still not a function.
If you're talking about, in this case, if you're going to have x minus d and then x minus e, those have to be roots as well. If it's going to be written this way. Because remember, if these are roots, then this thing is going to equal 0. And then what happens when we have a product equaling 0? One or all of those are going to equal 0. Okay, so now, keeping that in mind, write a polynomial with the functions of the function with the given root -2, 3, and 1k is positive. Just plug it in. Plug what in where? A, B, and C. Is there a C here?
No.
No. So we just plug it into what? A and B. Now, I don't know what K is. Okay, we're gonna keep it as small as possible. Okay, we'll just say K is a positive 1. Okay, make it easy. Now, does it matter what it really is? No, I can write the polynomial to anything as long as I just include that K. Okay, so we'll write it just as if k was a positive 1. Well, how do I write it? How do I write it? Plug it in. Plug what in where?
-2, 3, K.
I don't plug it in right. So I take this, y is equal to, take k as positive. We'll just say x minus a times x minus b. Well, what's a? -2. So what's x minus -2?
X plus 2.
X plus 2. So y is equal to x plus 2 times x minus 3. Now, if I ask for it in standard form, what do I have to do? I have to multiply this out. I have to do the FOIL. Well, if I do the FOIL on this, what do I get?
X squared.
-6.
X squared
Minus 3x.
minus 3x plus 2x, which gives me
Yeah.
negative x.
Negative x. Minus 6.
Okay? And that's it. There's your polynomial. Okay? There's your polynomial.
It says k.
K. K is positive. So what we would technically have is that, some k times that. Okay? Because we gotta bring in that factor of k times this. Well, all that means is what I'm telling you, k is positive, k is negative, is whether we are going to, left side going to be going up or down, right side going to be going up or down. Okay? And it does change some things between with the function, right? But we're good right now. Okay? Now, let's say this is k is a -1. What happens when k is a -1?
It's like negative k.
Okay, well, not just negative k, we have a -1. So I'm gonna have a -1, so my polynomial now is gonna be a -1 times what?
X plus 6.
X plus 5
X plus 3.
x plus 3
Negative.
X minus 3.
times x minus 1. And now what do I have to do?
Okay. Well,
Multiply it out. I gotta do the FOIL and then I gotta do the sugar. So then if I do this, x times x, x squared, so I get -1 times x squared. That's 3x plus 5 is 8x plus 15 times x minus 1.
That's like
So that's -1 times x cubed minus x squared plus 8x squared minus 8x plus 15x minus 15. Well, if I take all of that and multiply it by a -1 and combine like terms, this makes this a negative, so f of x is equal to a negative x cubed. So that takes care of that guy. So that's going to be a -1x squared.
minus 7x squared.
That's going to be a positive, but positive times that negative does make that negative 7x squared. So it takes care of that guy and that guy. So we get, what happens here? 7x,
Negative
negative
minus
1,
7.
negative 7x. Done is done,
Positive 15.
positive 15. There's your polynomial.
That's so cool.
Yes. So what I'm telling you is that here are my roots. K is positive. Well, if it only has 2 roots, and we're looking at the smallest degree possible, K is positive, I have a parabola that opens up instead of opening down. Well, if I'm looking at the smallest degree here, how many how many zeros do I have? 3. So what do I know? What kind of polynomial am I going to have? Cubic. And if it's negative, it's going to look something like that. Okay? Well, down here, what's the degree going to be? 4. My leading coefficient is going to be negative. So, what's that?
There's 4 numbers there.
Degree.
It's like an M.
But exactly, x minus equal to 48 hours.
Richard. How many numbers are here? Right? How many numbers are here?
Yes. What is this called?
Power.
What power? What is it called?
Degree.
It's the degree. What's this one?
Degree.
The degree. The degree of a polynomial is equal to, at most,
The
equal
number of x.
to the number of zeros. Okay? So we can have at most the number of zeros equaling the degree. Does that mean that every quadratic has two roots? No. We have zero. It could be above and opening up. It could be below and opening down. Now, this is the number of groups that it does have, but if it has one, then what else do you know? If it has one real, it's sitting on the x-axis. If it has none, then it has two imaginary, or it's not sitting on the axis. It's opening up or opening down. Okay? Because the thing could have other solutions, but those solutions do not have to be real solutions. Okay? Well, down here, does anything change when we have 4? No. We're just going to have to multiply 4 times. Okay? And now k is a -1, we'll call it a -1. Okay? So now we have a -1 times x plus 6 times x plus 2 times x minus 1 times x minus 5. Right? And we could get that by multiplying those things out. Okay? Now, different way to look at this, look at number 2. Given that x plus 4 is a factor of f of x equals 2x cubed minus x squared plus 8x minus 16. Find the value of a and factorize f of x. I gotta find the value of a. How am I supposed to find the value of a? Well, -4 is not a.
-4 is 0.
-4 is what?
Root.
Root. Well, what can I do if it's a root?
Put it as A.
X.
B. I just said C.
A, B, and C are not roots. Do not confuse them.
X is
-4 is a root. Well, if I have a root, then what do I do? What did you do before today?
So divide it.
Substitution.
We substituted. Okay, so we could do a direct substitution to find that, or a synthetic substitution. Well, if I direct substituted in -4 for my x, what am I going to get? It's a root, so I'll get what back? 0. So that doesn't do us any good.
All right. Yeah.
Okay, so I don't want a direct substitute, I want a synthetic substitution or division. What am I going to do my synthetic division with? 4, -4. -4. So I take -4. What are my coefficients? 2,
no 1.
1,
Eight.
okay,
1. 8.
and
-16.
-16. You guys are paying attention. A is not a variable, A is a constant, X is not a variable. Okay, so now I just do my synthetic substitution, just like I normally would. What do? Bring the 2 down. -8,
7. 28.
28,
28.
28 plus
8 plus 4 plus 8.
okay? So remember, we're adding those together. Now, this guy has to stay as a term. So now what do I do with that 28 plus a?
Distributive property.
I use my distributive property and I multiply it by -4. What's -4 times 28?
-4,
-112.
-112
Oh!
minus
It's not good.
4a.
I'm not gonna do
Negative. So now, what do we get? -128 minus 4a.
How do you write that?
I write it just like that. -128 minus 4a.
Like in hard thing like that.
Well, I know that -4 gives me what? -4 gives me what? A root. What does a root mean when I do my synthetic substitution?
Yes.
Where is my 0? -128 minus 4a should come out to be a 0 if x plus 4 is a root. So, if that's the case, -128 minus 4a equals 0. Because we know that this is a factor, and if that's a factor, the very last term of my synthetic substitution is going to result in a 0. Okay? Well, if that's the case, then I know that -128 minus 4a.
4 equals
has to be-
-32.
I'm sorry, what?
I mean, a equals -32.
There you go. Don't get so excited. So yes, we add it, and then the a does equal 32. Well, now,
Negative.
negative. Now what do I do? Well, that's the first part. So we found the value of a.
Just plug it in.
So now I go back and plug it in. Now my f of x is equal to 2x cubed plus x squared plus a -32 x minus 16. So now that's my polynomial. Yeah. Yes. Now, if I go back, I could look at my synthetic substitution, or I can go do it again. Because if I plug this -32 in here, this also gives me my coefficients. So I could go back and take these coefficients and do my synthetic substitution again with -4. Or I could just take these and use those values. Well, if I do this with -4, I'm going to get 2x squared minus 7x. And then what's 28 plus -32? Minus 4. And then we know that this thing came out to be a 0, so that's gone. Now I look at this quadratic, and what do I do with this quadratic? Factor that quadratic. Can I factor that quadratic? Can I solve that quadratic?
Yes. Yes.
Yes. What do I do? -8. Okay, so 2x squared minus 8x plus x minus 4.
2x.
Factor out the 2x, x minus 4. Factor out the -1, x minus 4. X minus 4 times 2x minus 1. So what are the factors?
4.
No.
Oh, that.
X. So my factors are x plus 4, x minus 4, and 2x minus 1.
2x minus 1 is the same. 1. Why did 2 4s?
We were given 1.
Missed the 2x part.
We were given this person. This is why you guys need to pay attention instead of talk. You were given one factor.
Yeah.
Okay? So now, when we found this a, we plugged it back in, all of the a's were able to give us this quadratic. Then we took this quadratic and we factored this. X minus 4 times 2x minus 1 gives me 2x squared minus 7x minus 4. Now, these two give me this trinomial. This factor was given, so these three are my factors of my original polynomial. Makes sense? All right, do number 3. Except now, number 3 has a and b. Because now we have x minus 4 as a factor of x cubed plus ax squared plus bx minus 48. I'll see who's paying attention. Yeah.
I don't understand what you're talking about the last I can see I can. You can see 84. You can see X. You can see X.
Yeah.
I can see H, but I see H. Three is not right. Three. Say three. Three.
Are you guys worried about how you pronounce the number 3, or are you worried about how to do it?
No, should be the end of it.
Oh, so that's stopping you from doing this how?
Right on.
Oh, this is easy. So what should I do? So I do 2 negative 2 plus 8. And that goes all the way. Negative 12.
Anybody run into a roadblock? Roadblock? Not yet. Hopefully there's not.
Oh, you mean mental roadblock?
Like a problem in an issue in the problem that you cannot solve.
Roadblock outside.
Why would you need to ask that?
That's not like, why would they?
No, why would you there?
That's what I said. Why would they be-
No, but why would there?
That's what I said.
All right.
He said, why wouldn't there be?
Oh, why wouldn't there?
Try to look at it now. Have we got it yet? No.
16, 8, I found this maybe, but I don't know. I think that's
16 equals 44.
Get that?
Wait.
Oh my god.
Why not just go back here?
A equals 22.
And B equals 11. That's my theory. Should be equals 32 and B equals 11.
Okay, so pay by that.
I mean, B equals 22, A equals 11. How do you work that out?
Well, start at the beginning. What's that tell you?
It's a fact.
What does that mean?
4 is a 1.
So 4 is my root, so I can take 4 and I go into 1, A, B, negative 48.
1, 4 plus 8,
4 plus A,
16 plus 4A, 16 plus 4A plus B, then 64 plus 16A,
this is 6.
64 plus 16A plus 2.
64 plus 16 plus 4B.
16 plus 16A, 16 plus 16A plus 4B.
B.
Then what do you do?
Now, what do you know about that?
That's equal to 0.
That's equal to 0. So, off to the side, you know that 16 plus 16A plus 4B is equal to 0. That takes care of this bit of information. What's the other bit of information that we get?
F negative 2 negative 12.
F of negative 2 is equal to negative 12. What's that tell me?
When x is negative 2,
What's negative 12?
0. That's the fastest.
When I plug in negative 2 for my x, my y value is negative 12. So plug negative 2 in. So we know that f of x is going to be negative 12 when negative 2 cubed plus a negative 2 squared plus negative 2 times x minus 48. Well, nothing to do with the negative 12, so just keep it. What's negative 2 cubed? Not 8. Negative 8. Negative times negative times negative. Negative 8. Negative 2 squared. 4, so we get plus 4a minus 2. Wait a minute. That should be negative 2b. I'll put 2x. Negative 2b minus 48.
Isn't it plus 2b? Negative.
That's a positive,
4.
and that's a negative. Okay, so it was plus bx, but our x is negative, so it's got to be a negative 2b. Well, now, what good does that do? What good does this do?
You can have 2 equations to solve.
We have 2 equations. How many unknowns?
2.
2. How do we solve 2 equations and 2 unknowns? Can use your calculator. How to use your calculator?
Simultaneous equation solver.
Or I slap you in the face because I don't like that. So, yes, but most of you guys are probably familiar with the polynomial, and you can do the simultaneous equation solving. I just don't want you to rely on that. Okay? Now, that's fine. Okay? Completely fine and completely legit. And here's my reason for that. Because you guys are an IB prep class, if you go into IB and for some reason that polynomial gets taken off your calculator, you need another way to do this. So when using polynomial is fun, just know that there are other ways to do this. So we can use polynomial. Well, how else? We can graph it, okay? Put 1 into y1, put 1 into y2. Can use a substitution. We can use elimination. Okay? Any of those 4. Or if you know on your calculator how to put it in to a matrix and solve it using matrices. You can do that. So you have multiple ways to solve these. Okay? Perfectly fine to do these. Right? Which way do you want to do it?
Substitution or elimination.
All right, either one. So which one? Well, I would clean this guy up, okay, to get A's, B's on one side, constants on the other. So add 8, so that makes -4. Add 48, so 48 and 4, excuse me, 48 and -4 is 44. Is equal to 4A minus 2B. And then this thing is going to be 16A plus 4B. And that's going to be equal to -16. So now we got the A's and the B's and the constants lined up. Now what? So this equation is from this thing cleaned up. This equation is from this one cleaned up. Now, this is where I make the choice. Do I want to solve for A, plug A in? Do you want to solve for B, plug B in? Do you want to keep it like this and do a linear combination? Do you want to do anything? I would say just multiply the top by 2, or divide the bottom by 2, or divide the bottom by 4. Okay? What's that?
Divide by 2. Divide by 2. Divide the bottom by 2.
Divide the bottom by 2. Fine.
Yeah. No, the 4 by 4.
If you divide by 2, we're going to solve for B. If you divide by 4, you're going to solve for A. Okay? Doesn't matter. 6 one half dozen the other. So we get 44 is equal to 4A minus 2B. Divide that by 2, we get -8. Divide that by 2, we get 8A. We divide that by 2, we get 2A. Excuse me, 2B. Now we combine them, 44 minus 8, and get what?
36.
Positive 36. 4A and 8A, 12A. And -2B and positive 2B cancels out. So what's A equal? 3, not 22 or 11. So A is equal to 3. Now what do I do with that? I can come back up here, and I can plug it in there. Okay, so now 44 is equal to 4 times 3 minus 2B. 44 is equal to 12 minus 2B. Subtract 12. 32 is equal to -2B. So B is equal to -16. Now, find A, done. Find B, done. Factor the polynomial. Well, I gotta factor the polynomial. Great. Well, I've already done my synthetic division. So now all I have to do is plug in my A's and my B's to get my quadratic. So I carry this down, 1. Well, 4 plus A. A was 3. What's 4 plus 3? 7. 16 plus 4A. 4 times A, 4 times 3. Well, that's 12. 12 plus 16 is 28. 28 minus 16, you're back to 12. And then do I need to plug it into this guy? No, because you know what that's going to come out to be. What is it? Remember, 4 was a 0, so this comes out to 0. Okay, no need. So now if I go back to this, this is going to be 1x squared plus 12. And now, factor this guy. Well, it's a leading coefficient of 1. If it's a leading coefficient of 1, what can I do?
4.
X plus 3, x plus 4. There's 2 of my factors. I gotta include the 4th one, x minus 4. There's my f of x factor.
Where did you get the first one?
It gave it to us.
Oh my god. Oh, x minus 4. Oh.
So x squared minus 4.
Oh my god.
So it's not x, you want it as factors. You don't want it to go back in. Okay, there's no need to multiply those three back. Because if I multiply these three back, then I get back this thing with my a and my b. Okay?
So, yeah, steps.
Now, just stop and think about these. There are a lot of steps, and I need you to pay attention because if you're not giving this 100% focus, you will screw up. You will make mistakes. I can guarantee it. If you're on your computer sending emails and doing all kinds of other things and not paying attention, you will make a mistake. Okay? If you do not devote 100% attention to this, you will make mistakes. If you do devote your attention to this, this is nothing hard. Okay? A factor means we result in a 0 when we divide. That's the case, that's the key to this. Take this thing, set it equal to 0. That gives you 1. Second part is knowing your function notation, which you should by now very easily be able to pick that out. Okay? Know that that means that when y is negative 12, x is negative 2. Plug that in. That gives us our second equation. Now you're back to algebra 1 where you have to solve a system of equations with two unknowns. Okay? So all of the things that you are doing, all the tools in your tool bag are now becoming used in a single problem. Not just one thing here, one thing there, maybe one thing over here. All of them. Zeros, factors, division, dividing, polynomials, pluses, minus, algebra 1, algebra 2, everything is coming together in one problem. And that's you. Did you? Good. All right. Now, sorry, my nose is snowing. Now, take this and apply what we just had. There are a couple different ways to look at this. Now, what you need is on the document that is online. I made a mistake. I forgot to put those 4 points. Okay? Those points are not on there. If you did not download it and it didn't come through, it might not even be on there. So I might have to go and upload it. I keep forgetting I got to do it as a PDF because for whatever reason, Google and Mac don't like each other when they're trying to download these things. Okay? So if you need the sketch, the important parts of the sketch are that this point is the point negative 2, 0. This point is the point 0, 30. This point is the point 1, 0. And this point is the point 5, 0. Okay? Find a polynomial equation of that thing. Well, this problem is no different than the problem that we just did. It's actually easier. So see if you can figure it out, and then we'll go through it. There are several ways to do this.
얘. 너 내가 나는 얘가 네가 아니야. 비보드 가면 틀린다고? 존나 부른다. 어떻게 하는 거야? 이게 잠깐
Are we dead? Are we dead?
이래? 이거 어떻게 하는 거야? 절대 안 하지. 그게 나아. 항상 많아.
아이, that's a really fast.
나는.
So, anybody figure out the quick way to do this?
No.
There's actually two very quick ways to do this. No polysim in this one.
X minus 4 squared.
Put it into your factored form. If you know, start off with the exact same thing that we started. X minus A times X minus B times X minus C. How many zeros do I have in this? I have 3, so I have an A, B, and a C. Well, that's fine. So f of x is equal to sum k times, what's A? Negative 2. So what's x minus negative 2? X plus 2. What's B? B is 1, so it's x minus 1. What's C?
X minus 5.
X minus 5. Well, now the only thing is I got to figure out what k is. Well, and what's the fourth point I gave you?
30. 0, 30.
0, 30. What does that mean?
30.
What does that mean?
Y.
What does that mean?
B.
What does that mean?
30.
What does that mean?
That means it's a K.
What does that mean?
That means
30 is not my k.
Oh.
What does that mean?
That's the middle.
Uh-uh.
That's the center.
No, you're guessing.
Guessing. Sure.
Stop guessing and actually think about what that means.
It has negative 1 times negative 5 times k has to equal 3.
Why?
Because it's
What does that mean?
x is 0.
X is 0. Well, when x is 0, what's y?
30.
30. So, you know f of 0 is 30. Well, that's equal to k times 0 plus 2, well, that's 2. 0 minus 1, that's negative 1. 0 minus 5, that's negative 5. Well, what is 2 times negative 1?
Negative 2.
Times 5.
10.
Negative 10, excuse me, positive 10. So we get 30 is equal to 10k. So what's k? 3. 3. So what is my polynomial?
3.
Now I just go back up. F of x is equal to 3 times x plus 2 times x minus 1 times x minus 5. Now, there's a really long way to do this. Well, don't you know that when x is negative 2, what's y?
0.
0. So I could do 0 is equal to k, but I found k really easy. But I know what k is. K is 3. So I could do 3 times x minus a times x minus b times x minus c. I can go through that whole thing, and I can get 3 equations. One for a, one for b, or one with a, b, and c, second one with a, b, and c, and a third one with a, b, and c. Then I gotta solve a system with 3 equations. How many guys want to do that? Probably not. Okay? But I can. I can go through and I can set this thing up to find 3 equations. Yes.
But finding the 3 is the same process as that, right?
Well, once I find this 3, now I can go through and I can get it. But I can go through that. Okay? I forget. Or I want to use my calculator. Oh, you guys know how to get this from your calculator? Get out your calculator. No polysymbol.
No polysymbol, you don't understand the So delete that.
No, polysymbol will not help you on this. Do not delete it. Polysymbol has a lot of good value, just not here. Okay? So, you get out your calculator, go to stat. Okay? We're gonna go to stat, and I'm gonna edit. If I go to stat and I edit, I put all my x's in L1. -2, 0, 1, and 5. So I'll go stat, edit. So we're at stat, we have your home screen, hit the stat button, which is right there, right in the middle, two spaces over from your alpha. Now, you're in the edit tab, and I want to edit, so I go edit. All of my x's go in L1, all of my y's go in L2. Now, what kind of parent function is this thing? It's a cubic function. Anytime you put values in the stat, go back to stat. So once you get these values in, go back to your stat. What are you trying to do? Calculate. So we arrow over to the calculate tab. Well, in my calculate tab, I can look down here. No, I'm not doing statistics. We'll do those later. No, I'm not doing median. It's not a linear regression. It's not a quadratic. It's a cubic. So I either arrow down and hit enter, or I just hit number 6. Now, this is going to ask you some simple questions. Are your x's in L1?
Yes. How do you change to L2? Because mine was in L3.
Okay.
Got it.
You put them in L3, or this was in L3? I was going to say, it's not. You see that they're alpha. If you hit the alpha button, and then go alpha 1 is L1, alpha 2 is L2, alpha 3 is L3, and so on. So now you got L2. Frequency list, there we don't have a frequency list, just leave it alone, leave it empty. Now, the good thing is if you want to graph this thing, hit your alpha and then the trace button. So if you hit your alpha and your trace, what this will do is this will bring up these values. You can store this right into your Y1, okay, or Y3 or wherever you want it to go, okay? So now, I'm going to shove this over into Y1 so that I don't have to manually copy it. And I hit enter. Then it gives me a tab that says calculate. Yes. Well, there's your A, there's your B, there's your C, there's your D. The exact same values that we found. Sure. So if we go stat, edit, got those in. We go to stat, over to calc. Okay, in my calc, we come down to cubic, that's 6. X's are L1s, Y's are L2s. Frequency list, we don't have one. Store my equation, it's in Y1 already. If you want it, alpha, trace, enter, Y1, and then calculate. Now, what this gives you is this gives you the standard form. But if I multiply this out,
That was such a
3x squared minus 3x plus 6x minus 6. 3x squared plus 3x minus 6, x minus 5, 3x cubed minus 15x squared plus 3x squared minus 15x minus 6x plus 30, 3x cubed, done, 15x squared, negative 12x squared, done, negative 21x plus 30, which matches what you have there.
I don't get the alpha.
Sorry. Okay, so hit enter. Hit enter again. Enter. Now, wait a minute. Arrow up, arrow up. Push the arrow up. Now, hit the alpha key, the green one. And now, trace button.
People that should be free to.
What is this?
Those are your Y's.
It's cold, right?
When you do that, then your calculator
What did it?
will take
Oh,
whatever you
have
have here. Now, you go Y equals. There's some function that you just have to calculate in case you lose a graph. Okay, questions? So now you have two ways. If it's a paper one or a no calculator, you can get this by hand, by setting it up, K times all of the factors, if I give you the zeros. If you have your calculator, punch it into your calculator, all of the points, all the given points. Now, the good thing about your calculator, the powerful thing about your calculator, I do not have to give you zeros. I can give you any values. Okay? Now, you guys probably, I'm not sure, depending on your what you use your calculator for, you probably don't have your diagnostics on, so your R squared is probably not there. The closer that value is to 1, the more perfect, the more accurate this graph is. If it equals 1, it's exact. Okay? Most of the time, if it's a good fit, it'll be like 0.99 something, 0.9 something. Okay? But this one fits exactly, and it goes all the way through. Okay? Now, application time. Well, and this one is actually straight from your book, so it's also in your book. So it says, data below gives a speed y in knots of the Trident motor yacht, which is a very beautiful yacht. Okay, for engine speeds x in revolutions per minute. All right. So if you have an engine speed of 9 revolutions per minute, you're traveling at 6.4, hundreds. So that's 900, 1100, 1300, 1500, 1700, 1900, 2500. 6.43 knots, 7.61 knots, 8.81 knots, 9.86 knots, 10.88 knots, 12.36 knots, and 15.24 knots. What do you think you're going to do with those values? How are you going to plot it?
On the
We could do it by hand and be a lot of guesstimation, or I could take and put them into my stat.
900, right?
So we don't need to worry about the hundreds. We can just do the single digits. So if I go to stat, edit. Now, this very carefully, if you ever delete a list, don't freak out. All you have to do, you do not want, if I want to clear the list, I go clear, I don't delete. But if I accidentally delete it, the entire thing is gone, it's not coming back. Just go back to your stat, run a setup editor, and then go back to stat, and it will be there. So whenever you want to clear a list, use the clear button. So you arrow up and hit clear, enter, and it'll clear it out. Do not delete a list. Or you could just simply write over it. Okay, it's not going to change. So our X's are 9, 11, 13, 15, whoops, not 15, 15, 17, and 19, and then jumps up to 25. And then we have 6.43, not 60, 6.43, 7.61, 8.82, 9.86, 10.88, 12.36, and 12.36, and 15.24. So check your values, make sure they are in and correct. Decimal places are in the right spot. It's slightly different. I don't have a graph of this. I don't know what the parent function is. So I've got to get a graph of this. How? Well, I just put them into my stat, yes? What do I want to do? How do I graph from my stat?
Because that would,
You don't know the graph function.
exactly, that's graph.
Press it.
You should, when you go to
I know,
graph,
we
and
do
then you
smart.
mention in the y dimension lists.
Why is it already in there?
We go back to stat.
Now, first thing I need to do is go to your y equals. The last problem is still in there because you never took it out. Get it out of there. Now, unless you've been messing around with your stat plots, your scatter plots, that is not going to be hunted. Okay, so what I need you to do, it's a very shortcut once we get it, but hit second y equals or the stat plot. We got to set our stat plots up. So enter on stat plot 1, turn it on if it's not on already. Turn on your scatter plot, which is the first one. Make sure your x's are L1s, your y's are L2s. Now, your mark, it can be, for those of you that have a color, you can choose a color and a mark, I do believe, or just a mark. Mine's black and white, I don't get much choice. Okay, so once you get this, do not graph, because if I go to graph, I don't see anything. Because you didn't tell your calculator where to graph, so the last window that you graph is going to be the one that it uses. But your calculator is smart enough. Go to the little button. And you want stat, because that's where I put all of my stuff. So if I go zoom stat, your calculator is pretty smart. It changes my window so that it fits all of the stuff from my stat window.
Pretty cool. Useless. Why are you laughing?
Now, what kind of function does this look like? Looks like a linear. So now if we want to find the parent function, are we going to use a cubic? No. Are we going to use a quartic? No. You're going to use a quadratic? No, we'll use a linear. So if I go to stat, calc, my linear regression that I want is this first one. There are two, but we'll use the first one. Regression, x is L1s, y is L2s. Now, this one, when you do not have a graph, I strongly suggest that you store that equation into y equals so that you can compare it. All right? So hit alpha trace, we're there, put it in y1, and then calculate. Now, there's my equation. Now, hit your graph button. Your calculator put it in y1, you put in the numbers for the stat plot. Your calculator, you told your calculator to put the equation in the y1. Does it look like a good fit for your model? Yes. Okay. Another way to look, remember, if we look at this, we have the r squared value and the r value. Both of those are very close to 1, so this is a very good fit. Okay? When you're dealing with real data, you are almost never going to get an r value of 1. Okay? But, or negative. The r value can go between -1 and +1 depending on your slope. Your r squared value is always going to be positive. Right, because your diagnostics are probably off. So if you go in, there's two ways. The new way you can go into your setup, you go into your when you set up your stat plots, it should be an option to turn on. Or you can just go into your catalog, search for diagnostics, click diagnostics on, and it comes on. I think actually there it's in the mode. If you go into the mode, it will have the option to turn stats on and off. You can turn them on and leave them on. It doesn't change anything for any calculations that you do. Okay. Now, here's the second reason about storing this equation into your y equals. Because now we can go to this and say, okay, estimate the average speed of the Trident for an engine speed that is 2,400 RPMs. Well, 2,400 RPMs, is that my X or my Y? It's 2,400 RPMs, X or Y? That's my X. Well, if I put my Y equals, if I put that thing in there, then I can go to my table, second table. And now, all I have to do is jump up to 2,400 for my X. Well, if I want to change that, press plus for the change table. Well, start at table, change in table. Well, it's going by ones. Okay? It's going by ones. Well, 2,400 would represent what? 24 here. So what is my speed in knots, approximately? 14.84. So it's
Maybe you can-
almost 15.
You can still do that in the graph.
Yes. Okay, now, for the next one. What engine speed is going to give you a speed of approximately 14 knots? Well, 14 knots is my Y. So I scroll down until I get almost to 14. Well, 14 is between 22 and 23. Is it closer to 22 than it is to 23? It's about 22 and a half knots, between 22 and 23 knots. Okay, so your modeling can go both ways. All right. Now, you should be able to figure out the rest of it. So take number 6, sorry. Take number 6, A and B, and number 7, A and B. You should be able to get those done in the next 6 minutes.
Whoa.
Sure.
It's